Welcome everybody. Thank you for joining us on our webinar series, Saving Money in Oil and Gas Operations. This episode is specifically for LACT units and meter runs. We created this web series of interviewing subject matter experts to help learning curve and then to give out back to our industry and then hopefully educate someone. That way they can do their job better. So to get started, a little bit of housekeeping for you. These are all the ways you can get a hold of us. But if you have any questions, if you're new to Zoom, there is a Q&A section or a question and answer section throughout the presentation. You can be typing up your questions, and then I'll try to politely interrupt Bruce to get him to answer the questions, or we'll wait it to the Q&A section at the end. Now, if something goes wrong, I know a lot of us might be working from home, might be driving right now. So no worries about that. What we will do is we'll have this video uploaded to our blog and our YouTube channel so you can watch it at a later date, or you can pass it on to some of your colleagues that you think might benefit from this. So again, my name is Cameron Croft. I'm the CEO of Croft Production Systems, a company that specializes in natural gas processing. And why you actually came to this webinar today, you wanted to hear from Bruce. He's a regional manager currently of Flow Services, but he actually started his career in 1959 in gas measurement, getting into chromatography in 1968. The last few years, he was area manager for oil states, manufacturing facility and meter runs and LACTs and pressure vessels. And then the last 4 to 5 years, he's actually been regional manager for Flow Services, a company that specializes in oil and gas measurement, in fabrication and automation. So in talking with Bruce and trying to outline how he can share his information with us, he kind of put a quick template together in this presentation, focusing on meter runs case studies, things that he's seen in the past and the information he wants to share, LACT units, LACT unit case studies, and then his tips and recommendations, wrapping this thing up at the end. So Bruce, I mean, everyone kind of wants to know, why did you want to be a part of this series?
Well, I think this is helpful, and for me, the amount of time, because I am the old guy, whatever I can share that's of any value, because that's not how I grew up. Most people were fairly guarded about what they knew, and when I began in this game, and it'd be a lot easier for everybody if they can just drag information out of somebody, and I just like to share. If you ask me a question, I'll give you a true answer. I don't have anything to protect, and it just makes life easier if you got somebody. And I feel like that I have enough experience to be able to offer something that's just not nonsense. It actually applicable.
Well, I mean, starting in '59, you've seen quite a few of these downturns.
I've seen quite a few of these. '66 was pretty bad, and obviously '74 during the oil embargo, and then everybody remembers '82, '83. I've not ever seen anything exactly like this. But they're all the same thing. Everybody suffers. I mean, it's throughout the industry when one of these happens. So at points, there's been where oil would go up when gas went down, and gas would go up when oil went down, and there was some balance if you were in both segments. This one's got both of them, and I haven't seen that before.
Yeah, that's right. Well, I know starting off, yeah, if you want to explain a little bit of this slide to us, you're kind of telling us the equations behind the measurement of LACT and meter runs. Is that right?
Yeah, typically on meter runs. So the reason I put this in there is, and I assume that people that are watching have a pretty good knowledge of what's going on. But essentially, what we're looking at is this is about 300-year-old technology as far as what we're doing. So it's not new. The the equations that we use and the principles that they're based on, certainly from the 1700s. They didn't make meter runs and stuff then, but the principles are the same. And so there's a pressure drop and a pressure differential, and it can be done in several different ways. I just wanted to kind of say that we're not reinventing the wheel, and it's something that we've known how to do for a long time.
Well, and that's what, like you said, 300-year-old equations. I think I was looking up in a book, the first LACT unit was in 1955.
1955, yeah. So that's not a new invention either.
No, so meter runs and LACT units, it's not a new technology. So it's really just coming down to kind of like maintaining the equipment itself, making sure it's good quality stock, good manufactured, and then you got good service techs actually maintaining this equipment. Because I think on the dry run, you were saying that, I mean, of course, everyone agrees on what it measures. Everyone's agreeing on that. Yes, that's what we're selling, or that's how much oil we produced. I mean, so there's a lot riding on, is this measurement correct?
Exactly. And so what you have is, I mean, you have a way to calculate by using some of these some of the things that we're doing here, these equations and some of that are baseline stuff. Now, is that actually true? Can you get it down to a cubic foot of gas that's actually going through there? Probably not. There's too many correction factors that are involved. But what you can do is you can agree that based on that this is what's going through there, and I will pay you this amount because we both agree that's how much gas went through there, or how much oil. None of it is, as far as I know, unless you were to break it down molecularly, whether that's actually true or not may be different, but we certainly agree that that's based on what we know, and using this technology, this is how much is going through there. And if you agree, then here's my dollars.
Yeah, so there's a lot riding on it. And I know, so your first one, you're talking about meter runs, and that's how we're starting off. So
yeah,
this Orifice fitting compliance, I mean, what do you mean by this? Are you just kind of going through all the compliance measurements for meter runs?
Yeah, so what you had early on was you had pipe, and you had OFUs, or orifice flange units, that were put in there, and you put a plate in there. And some of that could have been misaligned. It could have been, the sizing could have been all over the board. And that was the old, what's called the 85 edition. And they approved on that. So you had to meet certain criteria going forward so that we could correct for how the flow was. So like on this one, the actual bore diameter all the way through it, the tap hole diameters, how big are they, locations relative to the plate, the eccentricity, seat gap. There's several different things that they decided that we needed to make sure were the same throughout, and everybody complied, and that way you could agree. So some guy didn't have an old 85 edition tube and was trying to balance that against newer compliance fitting things. So if you're going to have custody transfer, we all need to be in agreement that it's all going to be the API 14.3.
Because the 14.3, that goes into, I think that's on your next slide, but that's standard for legal obligations. So the U.S. custody transfer gas contracts, they demand that, right?
Right. This is what they're going to want, and you got to build them to this, and this is what they got to. And the reason that they're doing this is just like it says. So you're tightening all the tolerances, essentially, and you're making sure that this one is exactly like that one. And that way you can, when you have a custody transfer, in other words, where the cash register is, where the dollars change hands, it's as accurate as we know how to make an Orifice meter.
Okay. Well, that so improved performance, reduced tolerances, and usage of actual dimensions resulted in improved meter accuracy. So that Is that something that, I guess, just improvement over the decades?
Yeah, exactly. So like I say, back when we had the old addition where you had 5 foot of pipe upstream and 3 foot of pipe downstream, with an orifice flange or even an old fitting. So what we did is basically the main thing is to make sure that the bore of the orifice plate is in the center of the flow. That's called the eccentricity. You want to make sure that the gas is in the center of the pipe, is where it's been, not over to the corner or one side.
Mm-hmm.
Also, how that we can condition the flow where it's not swirling and moving in a bunch of different directions. So either through a longer pipe where it has time for the flow to get straightened out, or use a device that will straighten the flow out so that it hits the orifice plate at the same place every time, and the bore where the differential is going to be measured is in the center of that, and everybody can agree that that is the best place for the measurement. And also that the tap holes where they're going to, whatever you're using as far as recording, whether that's an old Barton, old mercury meter, or an EFM, that those tap holes, and we could go into why they're there, but they should be 1 inch upstream and 1 inch downstream of the orifice plate. So where the differential has gone through cone shaped and starts to spread back out into the pipe or the vena contracta, that is where that flow, the pressure drop, is actually measured. And it's always the same as long as you have those locations. Exactly.
And that goes into so the 14.3, that's American Gas Association, American Petroleum Institute.
Right. And AGA has the same part, or AGA 2000 or whichever current version that is. API has, it's basically the same thing. They work with the same thing. We use API 14.3. That's the most accepted. But AGA also has those same.
So with these applications, on your next one is orifice fitting requirements. So I know this is something that y'all as a company does, but yeah, tell us, what do you mean by no abrupt changes can exist inside the meter tube? I guess because it interrupts the laminar flow.
Exactly. So everywhere where you weld the pipe, you can't just leave that root pass inside the pipe, or because it'll disrupt the flow. And it's also not the same size. So when you build one, you've got to come in and you've got to grind that internal root pass out to a tolerance that's the same as the internal diameter of the pipe. In other words, it should be from the moment that it enters the flange all the way through that meter tube until it runs into an obstruction, which would be downstream the first thread left. Would be an obstruction or any protrusion into the pipe bore. So you want that flow, you want that internal diameter to be exactly the same all the way through there, so that when you do a calculation, when you make a basic orifice factor of ID plus the specific gravity and all the other Reynolds numbers and things that you have to correct for, it's always the same. That flow is all the same all the way through.
Now, if protrusion is in there and you start creating a turbulence, does that, I know there increases the probability that error might happen in the measurement. So you could actually be giving more gas to the pipeline without truly measuring that gas?
Yeah, I mean, anytime that you have a disruption, that, depending on what's happening, could be over measuring, it could be under measuring, and knowing that which one it is not easy to figure out. But it will be off anytime that you disrupt the flow and it hits the bore of the orifice plate. off center, then you've got an unaccountable error. I mean, it's going to cause you a problem.
All right, so there's
Got
been
some uncertainty in it, I guess is what I'm saying. There is uncertainty within that.
so there's been some changes made. Yeah, so tell us about these changes.
Okay, so used to in the old 85 edition, like I say, if you had a 3-inch meter run, you put 5 foot of pipe up front and 3 foot downstream. And if you had 4-inch, well, that was 6 foot and 4 foot, and that was all. So what they did is they did enough research on it to find out that you would need a certain length of pipe to make sure that the flow has had time to correct itself coming out of the L's or bends or however it gets into it. And typically, 44 diameters, if you're coming off of just 2 L's. Now, if you're coming out of 2 out-of-plane L's, you could be as much as 145 diameters of pipe you would need to straighten that flow out. And that's worst case scenario, 145. So 145 diameters of 10-inch pipe is not going to fit on a trailer. So
Yeah.
So you're going to have to correct the flow, which is where the tube bones and flow conditioners come in. You can do that in a lot less pipe, 17 total diameters instead of 44 if you're using the flow conditioner, 29 diameters if you're using an old 19 tube bone. That changes it.
That kind of goes into your next one with the pictures here. So the section 4 categories, you got 3 major areas. I guess the top one is the least expensive, and it keeps getting more expensive as it goes down. Is that right?
Sure. So in a bare tube, again, you have this 44 diameters of upstream without using any kind of flow correction device in it, and as much as 145. So 19 tube bones are getting harder and harder to find. They were 7 tube bones a long time ago. They changed it to 19 tube bones to try to correct that flow, and all they are is just stainless steel pipe, all put together so it would flow into it and try to correct the flow.
Now,
those are getting, and Gallagher's is another device that does the same thing.
Why 19? Is it just because that was a standard size for the stainless, and then they were able to fit 19 tubes in there?
Yeah, exactly, and it may do what yeah. So what it was they thought 7 would be enough to correct it, and through some research found out, well, we need more. So it turned out 19. But those are almost obsolete with the flow conditioner. Whether you're using a Canalta profiler, if you're using CPA's 50E, or there's a couple of different folks that are out there, but those are the 2 basic ones, and they use velocity as well to correct the flow, and so that flow coming from it, or whether it's flange mounted or whether it's pin mounted inside the tube, is the best way to correct the flow so that it's hitting the plate with the laminar flow and perpendicular to it. So that it's the way to do it. And I wouldn't, if I were ordering stuff new, I wouldn't even consider anything with a tube bone. Flow conditioners are cost effective, and certainly ice has a harder time bending them. You get 2x4s and bunny rabbits and ice coming down the pipeline. They're a lot better for dealing with that than like a tube bone where you cave it all in. You might not know, or it gets stopped up, and the flow rate changes, and you don't really know why. So flow conditioners are definitely the way to go cost wise.
Yeah, I think that's pretty funny when you have to do a tensile strength and then also test it against pebbles and bunny rabbits going down the pipeline. So,
and trust me, that happens. Yeah. So
I can only imagine how much trash actually hits that flow conditioner.
Well, even now, when you're with the amount of sand it takes now to open up these horizontals, you're always going to be getting sand back. And
Well, we actually had someone on the webinar ask a question. Do flow conditioners also reduce your upstream pipe length?
it will. So in the accepted here is that you have 17 total diameters of upstream pipe. CPA out of Canada, which builds a great flow conditioner, they've tested theirs to as small as 13 diameters. That was done in Canada. Maybe a few years ago, we built a lot of them that were 13 because people were trying to save a little space. But since the data doesn't recognize US, we still build them at 17. So that's 10 and 7. In other words, from the flow conditioner to the orifice plate would be 10, and in front of that would be 7 diameters.
Well, and that's what it kind of goes into your next one was the pipe compliance. Is that the pipe compliance before? Is that what we're talking about? Is it the same thing? The pipe length?
So what you need is you certainly need seamless pipe because you have tensile strength that you need. Welded pipe, which is ERW, electronically welded pipe. That's not going to do it because they don't have the burst strength and don't have the tensile strength for what we're talking about to reach, say, 600 ANSI, which is 1,480 pounds MAOP. So what you look for now and what you have to have is A106 grade B cold drawn seamless pipe. In other words, that pipe is, as it's cooled, it's drawn over a mandrel so that the internal diameter is exactly the same all the way through. And you can have that honed to basically any size. But the A106 will give you strength up to 6 inch, schedule 40, will make 1480. 6 inch and butt, you got to go to schedule 80 pipe, just so you get the tensile strength and the MAOP if you need 600 ANSI. So it is the pipe that you use, and basically that's because the internal diameter is the same all the way through.
Now, if you have existing meter runs on locations, is there a way to inspect to make sure that it's still meeting those tolerances and those quality levels? You would need, I guess, an MTR beforehand to see how it was built, to see if there's any erosion or corrosion on it.
Yeah, exactly. So, typically what you'd like to do is at least every once in a while, is take that tube out of service if you're able to, and pull it apart, clean it up because it's going to be full, and we have some examples of that. It's going to get used unless you're pipeline quality gas, where it's just methane, 98% methane going down through there. If it's going to have other stuff that goes through it. You're going to carry over water. You're going to carry over oil if you're using it at a battery. And so take it apart. Make sure that it's that the internal diameter is still the same. It'd be nice to have the MTR so you know that that's what that pipe is, because you can't tell once you got it painted and in service.
Yeah.
So you'd want to inspect it and ensure it meets those, and that's where you save money. Is some kind of routine maintenance, even on a meter tube. I get that it's $2 a thousand, and maybe that cost is because no more than you're getting. I get that, but it's still $2 a thousand. You're not giving it away.
That's right. That's right. And that kind of goes into the meter tolerance on the next one.
Yeah.
So your approval was saying maintaining tolerance. I guess do a mic check or pipe length diameters, making sure everything's still in good condition.
The first thing you can do is just go out there and put a tape on it. Just make sure that the pipe's long enough. You start at the orifice plate, so the center of the tap holes, from there to the upstream and there to the downstream, and just make sure that you got enough pipe to begin with. I mean, if they're built at a reputable manufacturer, that's and you bought them in the last few years, sure, that's probably okay. But if you got some stuff out there that you're using as custody transfer that maybe you just found in the back of the yard and you stuck in there, you might want to certainly make sure that you got enough pipe up. Then you can do that without taking it apart. Then if that's correct and you want to check it, you could certainly pull out whatever device you have in it for the flow. But you'd want to break it apart at the flange and do some, just do some internal micing to make sure that it hasn't, wallowed out yet, or it's full of pits, or there's no bunny rabbit stuck in there somewhere.
Well, that's what so the ultimate goal is, like you said earlier, is trying to get to laminar flow.
Yeah.
So that's with a tube bundle or the length of pipe or the profile conditioner.
Right.
And then it goes to the correct size of the orifice. So like on the life of a well, if you have that decline curve and then they have so much volume decline or a pressure decline over time, what will indicate to an operator that it's probably about time to change out the orifice, or there's enough error going on that something needs to change?
Yeah, so that flow is certainly gonna, at least on most of these horizontals, it's gonna fall off. Those things will play out, and there's no secondary or tertiary stimulation that you can do for them, at least in shell play. So it's going to start to go down. And once the thing gets out of good range on whatever you're using as a recording device, and most everybody's using some electronic meter, I get that part. And if you got a 200-inch device and you've been running 150 and now all of a sudden it's down at 50 inches or something like that, and the pressure's starting to drop down, certainly you're going to want to change the plate, but you got to stay within, and that's the one thing because you have so much room within these transducers, you have to stay within some kind of beta ratio. In other words, a ratio of the pipe to the bore of the orifice plate, and you want to try to keep that in about 0.67. Because it's better accuracy if you keep that beta ratio where it belongs. Now, keeping the beta ratio and the thing won't even register on the recording device, then you may have to drop down. If you got a 6-inch in there, you may have to go to a 3-inch.
There's a turn down rate from each side.
Yeah, exactly. Yeah. So just because you have a long range of 0 to 250 or 0 to 800 DP on there doesn't mean that you can still record that accurately.
Well, I imagine most manufacturers, if you can just reach out to them, they'll kind of give you that knowledge. But is that something Flow Services will do? If they say, this is my new flow, this is what we're seeing out here, is this the right size? Is that something?
Exactly. We can do that calculation for you and let you know whether you're staying within that beta ratio. And it's, maybe you could, and that's what it's going to take. Here's what my flow was when we put it in. This is where we're at now. And still we've got 10 of these in laterals over here. And when they get to the master meter, well, we've got all this unaccountable.
Right.
We can certainly help you figure out at least where you may be making a mistake. Yeah.
Well, we have one client right now that has they put an initiative together during this downtime to kind of get their house in order. So they're actually, one of their initiatives is they're pushing their lease operators and pumpers and gaugers to check everything, go to their LACT units and meter runs, and then trying to make sure that everything that they're selling is actually selling. Squeeze any dollar they can out of this thing. So that's something that they could ship that over to y'all, and y'all can say y'all's recommendations of, yeah, you're in good order, or no, you need to start changing something.
Yeah, exactly. And that's, you'd have to see what it is. And I mean, there's a 100 different things that can happen, and these guys, I'm sure, know all that. Maybe you got a low spot in the line somewhere, and you need to pick that out, and things are backing up, or the separators, that dump valve doesn't work very well, or blah blah blah. I mean, there's 100 different things that could happen.
Well, that kind of goes into your next one is if they're already out there and they're getting these. Now you put a series of pictures that you shipped over. This is what they should be looking out for also, right?
Yeah, exactly. So, on a couple of these, when we look at these, you've got, these filthy and coated, with a lot of salt on the flow conditioners. The other ones are just pitting and what can happen to the pipe if you've got CO2, H2S, and water all going through there, then you got carbonic acid, and they're going to start chewing things up.
Right.
They'll start pitting pieces together. Maybe somebody bumped into it with their pickup and put a dent in it. I don't know I've seen a lot of weird stuff. But what you want to do is take it apart and see what the internals look like. I mean, you can see that on a lot of this, there's a lot of pitting just because of the water or carbonic or combination thereof. And once you pit those to that point, you're losing accuracy in your measurement. And,
yeah,
and chasing ghosts out looking for a leak or something like that when it's all in here. And you don't want to get caught up in chasing a bunch of ghosts.
Well, and that's the next one also. So the one on the left, explain, when you shipped this over, I had no idea what this was. I didn't know if it was like an eddy or something was eating at that. So what is that?
Yeah, so what it was and we didn't do this. So let me start there. But
disclaimer.
Disclaimer. Apparently, when they were putting the CPA or the profiler or whatever flow conditioner, it didn't quite fit in that flange, and so they sort of hammered it in there, and it caught the edge of that flange and dug out a little groove and pushed it all up against the side there, but it got hammered into position. That flow conditioner should fit in there, whether it's Schedule 40, Schedule 80. It's designed to fit inside, and if it doesn't, then you need to find out what's wrong with the flange. So, which means you should be marking the flanges as well as the pipe.
That's right. And then on the right hand side, is that the 19 tubes?
Yeah. So that's what I was saying. Stuff will get in there, and the first thing it's going to get is the easiest thing to clog up or bend up, or a chunk of ice, and that certainly happens with a huge pressure drop somewhere or another. You create ice. You got whether you have free water or whether you have entrained water turn into ice, and a big ice flow comes in, and they're hard behind pressure.
Yes.
About 600 pounds, they will start tearing stuff up.
So y'all seen hydrate formations just start pinging and locking in?
Yeah. Oh, yeah. So you're going to have that, and they're going to beat stuff up, and so you have to if you've got ice problems or if you've got weird things, and they'll know people that are taking care of that lease. Probably want to take a look at things like the CPA, or if you have a tube bone or something in there, and certainly the orifice plate. I mean, bent orifice plates is a pretty common problem anymore.
Yeah.
Always have been. So if you can't get the plate out because it's got a little bow in it from ice hitting it, guarantee you if you got a flow conditioner in it, that's tore up too. So
okay. So pretty well, if you're having to change out the orifice, because it's been up, you might as well just start looking at the profiler.
Yeah, I'd start breaking it apart. Yeah.
And then your next set of pictures, these
are showing you, like I say, the first one is something bent that. I mean, that's not how it came. Something ran into it, so it put a big knot in the middle. So now it's not It's not even close to intolerance in that place. I mean, the ID has been altered. The pitting on the second one from salt and no telling what all has pitted that pipe up to where that's no good. Scale and rust build up in them as you carry over water, and that's going to happen to all of them. Well, that's going to affect your measurement, and if you're looking at that and it's all clean, then start looking for the leaks and all the other things that you might to find your own accountable. But the first thing is to start at the primary device that measures the gas and make sure that's good. And then you can work your way downstream to wherever the problem might exist.
Well, that kind of goes into the grandfather theory. I mean, just because you have stuff that's out there, and like you said, it's an old technology, there's not been too many technological advancements to it. But like from the pictures you were showing before, I mean, things could be so tore up that there's a probability that you might be like underselling or overselling.
Yeah, exactly. That's what happens if you have. I mean, there are older gathering systems and stuff that are out there that have been for a while, and they've been altered or they've been moved around, or it came from this old location that we closed in and we moved it over here to this one, or they just haven't been there because of the grandfather. If you had an old one and it was in situ, then you get to keep it there. You don't have to, unless your contract says you got to change it out.
Yeah.
But if they're in there, they're in there. And if they've been in there very long, there's probably something wrong with it. Now, again, we're talking about saving money, and I get that part and how you would do that. But cost of, if you've got a 7 or 8% unaccountable on the whole system, or 2% or 5% unaccountable, that's more than pay for a couple of new meter runs to correct that, if that's the problem.
That's right.
If you've got this old grandfather stuff. So you'd actually save money by buying something new, depending on the percentage of unaccountable and how much gas you got through the system.
Well, that kind of ends the meter runs, but the LACT units, yeah. So explain to us a LACT unit.
Okay, so in the way that a meter tube measures gas, a LACT unit is exactly the same thing in that it measures oil. We've been building those things since '55. They basically all do the same thing. They have some way to determine the BS&W, or the base sediment in water. You've got a device to create a better flow rate, which is just a mechanical straightening vane, so that you can take the sample. It's measured through, Coriolis is most predominant, but you have PD meters, or you've got turbine meters, or I mean, there's been several different ways of doing it. Currently now, Coriolis is the way to do it. Their technology, their software, their voodoo is better than an old PD meter in accuracy. Then you got to have a way to test that, which is the proven loop, some way to hold some back pressure against it, and then sell it. Then you have a pot that takes a sample, and that way you can come dip into the oil, drop in a hydrometer and check out the gravity, and shake it out and see what you got. That hasn't changed. That's always been the basic componentry that measures oil.
Well, and that measuring oil, so again, since your years of experience in LACT units, I mean, you've seen some, I guess, custody issues, right? I mean, everyone's agreeing that this is how much oil we're selling. So I can only imagine some landowners are, they might feel like they're getting gypped, or some royalty owners are
exactly
upset.
You have in the Eagle Ford particularly, That is real light crude. It's condensate. It has a lot of light ends that flash off. It's hard to control because of the vapor pressure. So
that's your case study right here. This is what you're talking about, right?
Yeah. So you can't really catch that in a pot. So what you're looking for is a proportional composite sample on something as light as that is the best way to do that, so that you don't get an argument over what flashed off and what remained. Back in the old days, we used to flash off all the light so that we could find out what 26-pound gasoline was. I won't go into that 1960s in great detail, but that's typically how it was done back in the day. So you want to be sure that, and the landowner wants to get paid, and the royalty owner, everybody wants to get paid for what's actually coming out.
Right.
And if it sets in even in a pot with the kind of vapor pressure that's on some of that really light crude, it's going to bend off, and it's not as accurate as trying to catch that in a proportional and composite sampler. Which so I think you don't need that everywhere, certainly in medium crude, certainly heavy crude, obviously not, but in real light stuff like you have condensates that you have in South Texas, particularly, most people are trying to put a composite sampler on.
So the light crude, I mean, I guess the meter says that they sell 50 barrels, but then after it starts flashing off, they might only have 25 barrels sitting in the tank.
Yeah, exactly, and it's it's certainly not component wise what they're hoping that is, because there's so much that you can do with that. Although we don't have any light crude refineries, there's a lot that you can do with that condensate that comes out there.
So that YZ sampler on the right hand side, what does that do?
So what that is, that'd be like a 5-gallon pot that keeps it under the pressure that it was caught in, and then it puts it proportional to the flow into a cylinder that's attached to it, and that cylinder, once it's completed that monthly run or whatever, then you can send it in to a chromatograph lab. They'll run that liquid sample and tell you what all the componentry is in that.
Okay, so at that point, then you can go back to these landowners or someone that says there's a discrepancy, and you can say, look, based on this, the calculation, this much is going to flash off.
Yeah, you know what you have. You have exactly what went through that. Depending on what the contract is, how that's written. I mean, there's a jillion different ways that contracts are. Some people don't care, but if they do, and the contract's written that way, this is the way to get exactly what it is that you're selling.
Huh. Yeah, we actually have one client right now that with the summer and the heat, the temperature rising, he's actually, I guess everyone's penny pushing, but I thought it was kind of ingenuity on his side. He's increased his pickup times because he understands he has light crude, he understands the temperatures, and he's trying to sell as much as he can. So he actually increased, he ran the economics on the truckers and said, I need to increase my pickup time, my intervals.
Yeah, no, I mean, everybody in this environment, and we should all the time. I mean, no matter whether it's $3 a barrel or $100 a barrel, we ought to want whatever it is that we've got. We should care about what the makeup is and the volume is, no matter what the cost is.
Yeah. Well, your next case study, you have properly sizing for added wells. So what do you mean by that?
So here's what happens. So you've got a 3-well pad, say in the Permian or Delaware, wherever in the shale play, and the current thing is we're going to put this is a 3-well pad, and each one of them is going to have, we're going to make 1,200, or we're going to make 2,500, we're going to make 32 if you're XTO, 100 barrels a day, and it's all going to go into this 10, 12 tank battery. We need a LACT size for that. And that's all good based on what they told you, and you can do that. But again, it's oil field. that may or may not be what what they actually produce. You may decide that a couple of them play out pretty quick, or you have another pad you want to bring into that that location that maybe you thought was just going to be a couple of wells, and now you got. But at any rate, that's going to change. It's going to be up or down, and LACTs are at least certainly the charge pumps, the Coriolis. They don't allow a lot of leeway in volume and be accurate. You might be able to change out an impeller in a pump. You might be able to do a couple of things, but typically they need to pretty well be sized for the flow, and you got to be pretty accurate. You can't just say, well, it's going to be 5,000 barrels a day, but it could be 12,000 barrels. Well, which is it? Because it's one ain't going to fit both.
Well, and that's one of the instances that we're seeing right now is with the market the way it is, not everyone's going to be, they're going to be kind of cautious about drilling the new wells on that field. Right. So there might be some decline where it has that, they have an existing LACT unit and it's not having that turn down rate.
Yeah.
So the pumps has that on off. So what would you do? Do you need a whole new LACT unit, or what would be the things that you would look for to upgrade that unit?
I mean, there's probably a couple of ways that you could do it. I mean, say you had a 3-inch LACT with a 3-inch Coriolis, and it was based on 6,000 barrels a day or whatever. You could certainly drop that Coriolis down, to a 2-inch. If the flow is declining, yeah, you could put some eccentric reducers on there and drop that down into a size. Yeah, you got a lot of money in Coriolis. I get that part. A simple fix, not so much. You could change impeller. You could put a variable speed drive on one of them. They're fairly expensive as well. Yeah. To try to control it. But you got to try to figure out either where you kick it on and kick it off based on the tank and how much that's going to pull off. In other words, if you have that tank set where it comes on and runs X till it gets down to 4 foot or whatever you're talking about, well, and you're not putting as much oil in the tank, maybe that timing of when you pull it off and when you shut it off is going to have to change so that you got a full flow, so that you don't have cavitation or that you're starving it one way or another. So there's a couple things that you can do just in controlling how much gets to it. Maybe it runs once a day is all it ever runs when it was running all the time prior. Mm-hmm. And you can make some, but if it just keeps falling off, you may have to get yourself another LACT and move this one to the next new location.
Yeah, because that kind of goes into your next one, the LACT unit design. Everything feeds off each other to get a proper measurement. So I guess once you kind of get down to a value chain or a critical point, then you might have to throw your hands up and say it's time to get a new one.
It's time to do something. Yeah, if you're not going to start, and I think we both, my crystal ball is not real clear, but I don't see anybody drilling a lot of wells over the next week or two. So, they're probably not adding more production. And so you're going to get to a point, I mean, the typical life of these wells, I think everybody understands the life of these 7,500 or 15,000 foot laterals. They are what they are, 5-7 years, whatever that is. But it's a piece of fall off. And you may get yourself to the point where you're just going to have bite the bullet. You'd like to be able to slow everything down as much as you can. But if you don't do a bunch of that when you start starving the pump or you start airlocking it, mm-hmm. Your measurement's so bad it's worth buying another unit.
Well, that kind of goes into the good tips you have for LAC units. So when you said fail safe and tamper proof, I guess you're saying that's what everyone's consenting that that's the way of the measurement. So if you're going out there and all the lockouts are been messed with, I think everyone's going to get kind of pissy about that.
Not everybody's going to love that. Blaine and a bunch of those guys are not going to be happy about all that. So, rejects and that kind of stuff, you can't stand a whole bunch of that. Typically you're looking for a way to have all the valves where they're lockable. Used to, we had to drill and put tamper-proof seals on flanges. So that kind of stuff. But you need them tamper-proof and recognizable that they've been messed with. So you want to have them to be sure nobody's monkeying with them.
Well, especially with these prices right now, everyone's kind of have that built-up anxiety. They're not getting the mailbox money as much. Right. So I think that could potentially, if they go out there, they want to run their own audit and they're finding things that are not properly locked out, that trust factor will not be there.
Trust factor goes bad, and yeah, exactly. And so you don't want them out there, every week. Somebody standing around while you're trying to sell or do any of that kind of stuff. So it's best to have it where it's a system that is tamper-proof, and you want to have it to where it's a well-built, doesn't leak. They're all going to leak some, and it's got oil going through it, but at least it's small, it's containable, it's cleaned up, so that it doesn't look like a mess, and you're want to be sure you're on top of all the flanges and the bolts and that kind of stuff to make sure that none of that's leaking.
So I guess when these lease operators, pumper gaugers they're making their rounds, they need to be checking for leaks, checking that nothing's broken, everything's still in good condition.
Yeah, exactly. If your containment skid's full of oil or slot bin is whether you're doing that, you probably want to pay attention to them, and that could happen through the pump seal. Certainly, those leak. That's common. They're gonna wear out. They're gonna leak. That's all part of the game. There's no such thing as a seal that's not eventually going to leak the way the pumps run. So you need routine maintenance, and you need someone that can take care of that for you if you're not going to do it yourself. But seals are going to leak. That's just part of it. You could have your little 3/4 horse motors. They certainly could have leaks in them. You could have, because they vibrate a lot, so there's a lot of stainless tubing on there. You need to make sure that they stay tight.
That's right.
It is a LACT is a high maintenance, not as high maintenance as some other stuff, but it is, but it requires maintenance. It just rattles. It makes it's just got some maintenance involved.
Well, it's like filling up your vehicle. If you think that meter's not telling you right and you almost double the size that you have to pay out, I think everyone's going to get pretty upset about that. So
everybody's going to get a little bit of but just, routine maintenance is, you hate to do it because the cost is what it is, and you're trying to save dollars, and I get all that. But it's probably the cheapest dollars that you spend is staying on top of it.
Yeah, so this kind of wraps up your good tips. Again, meter runs and LAC units, that's your primary measurement. That's what everyone's agreeing on, what you're selling, so that way everyone can get paid.
Yeah.
So these tips right here, you have proved LAC units monthly, is that right?
Yeah, I think everybody does. So you'll have a proven unit come out. You got to prove that measurement device, whatever you use, PD or Coriolis or turbine or whatever, that you need that proved, and make sure that it's repeatable, and make sure it's within the custody transfer tolerance of 0.1%. So, you want to evaluate the volumes, like we're talking about, to see where you're at. If you need to correct the sizing one way or another, so you know where you're at. You're not just losing it through negligence. And on meter runs, there may be semi-annual. That's typically by contract. Could be semi-annual, could be annual, could be monthly. But you need those recording devices, whatever you're using, and the plate inspections and all that. Certainly, somebody's got to do that on quarterly or whatever contract calls for.
Yeah, based on those pictures, I mean, you got to inspect it internally.
You need to take a look at that once a year at least. I mean, break that thing down, take a look, make sure, because everybody proves somebody comes out and calibrates their recording device, whatever that is, whether that's an internal guy or they have a third party. But the recording device only tells you what it sees. It doesn't tell you whether it's correct. In other words, it doesn't tell you if the plate's bent or the CPA stopped up or if there's rust or scale inside the meter tube. It only tells you it's only a recording device of what's happening. Mm-hmm. So, the recording device works, but does your meter tube work? I guess is what I'm saying. That's the primary element, and you want to make sure that that's correct.
That's right. Well, wrapping this up right quick, we do have a Q&A section at the end, but the upcoming webinars, we have my Director of Engineering, Chris Misson, is going to be talking about JTs or Joule Thompson systems and fuel gas applications. Then we also have Chris Crow with Pristine Alliance talking about burner management and maintenance. Now, if you're interested in being a webinar speaker or know of someone that is a subject matter expert and you think would be a good fit, please do reach out to us. We want to share that knowledge with everybody. So you can reach out to the email below, tori.balagura@crosssystems.net. And if you're interested in processing webinar or a training conducted at your company, either with Croft or with Flow Services, you have specific questions for you and your engineer team, field technicians, please don't hesitate, reach out to us. Again, tori.balagura. That way we can do a Zoom call. Everyone's kind of locked up right now, or we could try to get to a location and make sure we PPE up. Now, you do have a survey at the end. So again, I'm Six Sigma, so I really love feedback, making sure that this information is coming to y'all clearly. Please fill out that survey so that way you can get a free hat or shirt, but then that also improves, make sure that these webinars keep getting better and better and better. So the Q&A section right now, we got Bruce and my information at the below. So if you don't have a question right now, please do reach out to us. We'll get your questions. As of right now, there's no questions in the section. So we're going to wait a couple minutes, but there is actually trying to figure out. There's one question I had for you earlier. So the profiler, if the profiler is damaged, you see that you're taking out the orifice and you put in a profiler. If it's machined in a certain way, like how do you go about trying to get a replacement for that profiler?
Well, there's only a couple of different manufacturers that you probably want to deal with. So depending on what you have, if you're using, and they're typically stamped. If you have a CPA brand, Canadian Pipeline Associates, they have that brand, it'll be stamped on there. If you have, which you can certainly call us and tell us what you got, and we'll get you one coming. Probably. They're interchangeable. One's not, if you've got something in there that you want, just tell me the size and the schedule, and we can probably get you something that'll work. And once it's tore up, it's tore up. There's not, you can't just take a file and kind of clean up the edges of it. But there is a fairly intricate manufacturing process to make those work.
Okay. Well, we do have someone from the webinar that asked another question. They said, what is the highest inch of water device you can use to measure 0 to 400 to 800 ? Will changing the DP measurement device allow you to measure a higher gas rate if you stay within 0.6 beta without changing the meter run?
Yeah, and they are right about that. If you can, that to stay within beta ratio is not always just the plate to pipe size. You can change the DP, the differential range to keep it within that. So if you want to go up to stay within that 6.7 or 7.5, wherever you want, just you certainly can. Go to a 1500 EP, go to an 800 if you got a 400, and that will keep you within that beta ratio by changing the range of the differential. Certainly.
All right. Well, there's no more questions, but the big follow-up is a lot of people have these initiatives with LACT units, meter runs. If they run into any of these issues, they can get a hold of you at Flow Services. What would be the best way to get a hold of you? I mean, you can get through Croft, but with LinkedIn or just reaching out to Flow would be best.
Yeah, I just reach out to Flow, and we have a facility here in Midland. That's where I'm at, and I have that number. You can call me on the cell phone, which should be provided on my LinkedIn page or whatever that number is, or I'll get it to you. Yeah. But if you call the Midland office, you certainly call Shreveport office. We have a place in Pearsall. So if you go to flow.com, you'll find all our facilities and where we're at, and all that info is available there. Perfect.
Well, Bruce, thank you very much for coming on and talking with us and educating us a little bit. We need all the help we can get. So.
Well, I appreciate you doing this, Cameron. It's very kind of you to invite me, and I hope it was worth doing. I mean, it certainly was for me. I hope something got something out of it. But I certainly enjoyed it. It was very kind of you.
Absolutely, Bruce. Well, you take care, and if you can get a hold of us in the beginning, and then this video will be uploaded to our blog. So take care, everybody.